This video is a special one-off of practice questions for our ionic and covalent bonding. These are questions I took from the end of chapter 4 that are relevant to subtopics 1 and 2. First question, which molecule is linear? The answer is B, carbon dioxide. To understand why, we need to look at the Lewis structures for these. And just a tip, if you Google a chemical's formula and the words Lewis structure, and then do an image search on Google, you'll find plenty of answers just like I have found now. First up, carbon dioxide has two charge centers, two double bonds around it. And of course they spread each other away from each other as far as possible, making a flat 180-degree molecule, so it's linear. If we look at sulfur dioxide, it has three charge centers around it, so they'll spread out into a triangular shape. However, we won't see the one lone pair, you just see the other two, so it makes a bent shape. For oxygen dichloride, I'm not sure if that's the right name, but it's late, we have four charge centers, two of which are non-bonding pairs. So overall, it's trying to make a tetrahedral shape, but again, we don't see the non-bonding pairs in the shape. So we see a bent shape like sulfur dioxide. And last, H2S is exactly the same situation as Cl2O. Four charge centers making a tetrahedral shape, but two are non-bonding pairs or lone pairs, so we don't see them, so we see a bent shape. So once again, this leaves carbon dioxide as the only linear molecule among these four. Second question. The answer is B, and frankly the best explanation for this is in the earlier videos for 4.1. Same thing here, the answer is D, and again you probably should just review my longer explanation of how to draw Lewis structures in the earlier videos. Once again, the answer is C, and again I think I've got a better explanation in the earlier videos. For this one, it's a polar bond because carbon and oxygen have different electronegativities. Now, to be thorough, you should be looking that up on a periodic table, either on the IB datasheet or ptable.com or any periodic table that has electronegativity values. However, I can just do it off the top of my head because I remember that carbon and oxygen are not neighbors on a periodic table. They're close, but nitrogen's in between. The point being, they're more than there's a couple spaces between them, so their electronegativity will be different enough that it will be a polar bond. For it to be nonpolar, they have to be very, very close. Second of all, we know it's a nonpolar molecule because of what we said earlier. It's a linear molecule. Therefore, these two nonpolar bonds are pointed at each other in exactly opposite directions, so they cancel out, and the molecule as a whole is nonpolar. Oh, there's a Lewis structure illustrating what I was just saying. Okay, next question. The answer is D, because ionic bonds are rather strong. Next question. The answer is B, just because. That's the whole point of VSEPR theory. Okay, next to last question. And a quick thank you to Rebecca who called me about this question earlier today, which made me think it through. Alright, the answer is sulfur trioxide. And to answer it, we should look at the Lewis structures. Again, just Google image search on the name of the formula of the compound and the words Lewis structure. First, H2CO. It would be trigonoplanar in shape because of the three charge centers. However, the carbon-oxygen bond is a different polarity than the carbon-hydrogen bond. So yes, the molecule would balance its three bonds, however those bonds are not exactly the same polarity, so it is a polar molecule overall. You're trying to balance some unequal polar bonds. If we look at NF3, we've got four charge centers but one lone pair, so it will make a trigonal pyramidal shape, which all the polar NF bonds will be pointing towards the nitrogen at the top of the pyramid, so it's a polar molecule overall. This shape is not making the bonds cancel out. In CHCl3, I believe that's formaldehyde. I could be wrong on that. you have 4 charge centers, so make a tetrahedral shape. However, one of those 4 bonds, the CH bond, is a different polarity. It's polar, but it's a different strength of polarity than the CCl bonds. So again, you've got a balanced shape, but not all arms of that balanced shape are equal strength to each other. So it's an unbalanced molecule overall. It's polar. And last, the correct answer, sulfur trioxide, 3 charge centers, no lone pair, so it's a trigonoplanar shape which balances out all the polar bonds. Okay, that's it for tonight. I hope that helped you, and as always, ask questions anytime.